We have two companies, two ventures that are going to pitch in the innovation track. A reminder for everybody tuning in, the runner-up, $1,000. The winner, $3,000. We're talking cash. So first up in the innovation track, Neo-Signo Sense with Raaghav, Malik, Soham, Joshi from Columbus Academy. 7 minutes to pitch. I'm going to come back with 30 seconds left. Then we're going to go 3 minutes Q&A. Raaghav, Soham, over to you. Your 7 minutes starts now.
Imagine living in a world where everything is pitch black and silent. This is a life for Emma, a deafblind college student majoring in elementary and special education. She has no vision and has minimal hearing with the help of 2 hearing aids. Emma struggles through college as she cannot communicate with her peers or participate in class, and speaking up has always been a challenge for her.
Emma has deaf blindness, a condition that hinders individuals to effectively communicate with the people around them and has severe effects on an individual's mental health and economic opportunity. What's worse, over 466 million individuals worldwide are deaf, and 97.6 million are deafblind. But only 20 to 30 million of these individuals who need care providers have access to them. This leaves over 58.5 million deafblind individuals worldwide who do not have access to the support service providers or braille devices that they need to communicate. And this does not even include individuals who are solely deaf or solely blind. The World Health Organization estimates $70 to $110 billion is spent every year towards deaf-assisted technologies in education, and 63 to 73% of this is spent outside high-income countries. Yet only a small percentage of the deaf and deafblind population is assisted. Additionally, in the next 50 years, estimates confirm that the number of deaf and deafblind individuals will double in size. So what do these 60 million individuals do?
Although deaf and deafblind organizations are working to help individuals acquire better communication devices, such as braille readers and writers, these range from $1,000 to $15,000 and require large laptops to display text. Because of this, national organizations spend lots of money to assist only about a sixth to a third of the deafblind population. The rest of the deafblind population must resort to using impractical yet cheap ways to communicate, such as communication cards, which consist of a pre-written message on a card. Deafblindness is clearly a huge emerging problem, and there needs to be a cheap yet multi-purpose solution that can adapt to the user's needs.
That's why we created Sense, a specialized, easy-to-use, novel sign language expert, which is a multi-purpose, wearable robotic glove-like device, which is designed to help people learn sign language.
As you can see in this competitive analysis chart, Sense is a unique product in the market. We can teach sign language at a low cost with personalized feedback, where our competition can't. An example is HIM's Braille Sense, which costs around $5,595 on average. Braille Sense simply translates text into Braille, which the user can read. However, when someone has to talk or communicate with others, this is a very tedious process. So that's why we created Sense, a novel solution that can teach students with sensory difficulties sign language at a lower cost.
We have also taken into account the function and anatomy of the human hand in our design. The human hand primarily consists of 5 flexor tendons, which allow for the flexion of each finger, and the palmar and dorsal interosseous muscles, which allow for the abduction and the adduction of the fingers.
This was helpful as we realized the primary muscle in use is the flexor muscles and tendons. By only using a single servo motor for each finger instead of a servo motor for every single joint in the finger, the device is designed to be much more affordable, with limited drawback and functionality, which allows us to drastically reduce the price of our device, costing us only about $110 to develop, including labor and manufacturing costs. And we expect to decrease this in the future as we continue to research more efficient motors. We plan to sell our device for $210, giving us a 48% profit margin. We started our prototyping process by creating a model using a 3D prototyping methodology. We then built a more sophisticated glove using 3D printed parts that could perform signs. However, we realized that these prototypes had many drawbacks, so we created our third and final prototype. This stage 3 prototype is our final prototype, with a device that fully encompasses a user's hand, with flexion in all fingers and abduction, adduction, and opposition in the thumb and little finger.
So how does this work? The glove consists of 3D printed rings that cords are threaded through, allowing for the finger to flex and extend. There's also a mechanism on the back of the hand to allow the thumb to adduct and abduct while still being able to bend like the other fingers. Instead of individually programming each of the 34 servos, we perform various signs in front of a camera. while the movement of specific key points on our hands is captured in a 3D space. Each key point is associated with a specific servo on the glove, and the angles between these key points are calculated to determine the appropriate position of each of the servo motors when the glove is making a sign. This allows us to easily train the glove to learn new signs simply by finding videos of someone performing their respective gestures, and many libraries already exist for this.
Our solution is split into 3 different modes: the training mode, the assessment mode, and the translation mode. The training mode is where the users can train themselves by moving their fingers into specific positions. The assessment mode is where the users perform these signs in front of the AI algorithm, and our code is able to tell if he or she is performing the sign correctly. And if not, they can get personalized feedback. The translation mode can be used when a deafblind individual has to communicate with others.
We've also done significant testing with the device and have confirmed it to perform the ASL alphabet with over a 92% mechanical accuracy. And you can see some examples in this video here. So here's a breakdown of our financials. We plan to have $1,035 in expenses per month in the original year and sell about 7 units per month, and our costs will be used in these areas. This will give us a total monthly revenue of $560 and a burn rate of $475. We expect to become profitable within 18 months as the number of units sold per month will increase and our product research costs will decrease. We need about $16,000 in funding, and we've already obtained a couple $1,000s from previous competitions.
We know customers will choose Sense due to its affordability undercutting the rest of the market by 1,000%, while still effectively teaching sign language. Stephanie Logan, a particular deafblind individual, states that sign language utterly changed her life, allowing her to communicate in a totally different way, and we hope many others feel the same way. Once we expand within the United States in the first couple of years, we plan to go worldwide, and our primary consumer will be international deaf and deafblind organizations, such as the World Federation for the Deaf and the World Federation for the Deafblind. These organizations are already spending billions of dollars to help those who are deaf and deafblind with assistive technologies, and we hope to partner with them so that we can market our product worldwide. Initially, we plan to get grants from the state of Ohio, who already spends millions of dollars to support deafblind education. Overall, we built a fully functional device that can effectively teach users sign language while providing personalized feedback. We hope that Sense will one day be able to help many people who are deaf and deafblind, or anyone who wants to learn sign language. We hope that our product will help those like Emma so that we can make their lives a little bit easier. Thank you.
Y'all, that was absolutely incredible. Love the innovation. So excited for what y'all are building. We're going to enter 3 minutes of Q&A from our judges for Sense. Judges, over to you.
This was brilliant, gentlemen. This is so brilliant. I love the use of acronym. I love the problem you're solving. It is so necessary, and it's always a reminder of just how much we take for granted. My question has to do with the testing. I wanted to learn a little bit more about that. Have you tested with other deafblind individuals? If so, what have been, what's the feedback been, and how are you trying to make sure that you're always testing so that you're on top of things?
Great question. So because of our current global situation, we're not able to actually have a deafblind user wear the glove and provide us feedback. But as Soham will talk about, we've contacted many organizations to validate our product and have had support from these organizations throughout our current progress.
Yeah, so we contacted some of those organizations. We contacted some deafblind support centers in Ohio, and we showed them our idea, and all of them loved it, and they gave us positive feedback. And so once we are able to test our glove, we'll be able to test it with actual deafblind individuals. But so in our preliminary testing, where we tested, can our glove make the signs? We found that it can about 92% of the time, which is really accurate. And so we're confident that our glove will work. We just haven't tested it with actual people yet.
I think that you guys, this was mind-blowing, and you may have addressed this and I may have missed it, but what are your plans for a patent?
Yeah, so that's actually what some of the funding from the Veale competition would go to. And so our first step is to get a patent. And so we're currently looking at different pro bono services for high school students so that we can get a patent at a lower cost. And so we expect this to cost anywhere from $3,000 to $5,000. And so once we get a patent, we then hope to start making partnerships with with some of these schools, and so that we can then start to sell our units and start to make more connections. But a patent is our first step, and we are looking into ways to bring down this cost.
Yeah, and we've already submitted an application for a provisional patent right now.
Awesome. Another question for you guys. I assume you guys are making these yourselves right now. Is that correct? How long does it take you to actually make one of the gloves?
So the stage 3 prototype that you saw here, it took us only about a couple of weeks to create it from start to finish.
And like when you go to like recreate that to actually sell them to people, do you expect that process will be faster? And I guess how do you, how will you be able to make them as efficiently as you can once you start to actually sell them in scale?
Yeah, great question. So yeah, that's definitely something that we're planning to speed up as we continue to develop, since we already have since we're 3D printing most of the parts in our glove, we already have the files already contained. And so all we need is access to a faster 3D printer, which we're also planning to allocate some of our funding into. And once we have that, we can just rapidly just create multiple prototypes just by using that same file and more like streamline that process.
Yeah, and just to add a little bit to that, a lot of those weeks that we spent to creating the stage 3 prototype were exploration in order to find the best ways to achieve what we wanted to achieve. And so that now we have all the parts ready, the process to actually assemble the glove is fairly simple. And we don't expect the glove to take too long to build. And with a pretty efficient process and with bulk units being produced, it should take a couple of hours to produce each glove.
So that is incredible. We know we're going to be watching and seeing how it goes. Thank you so much once again for Sense. All right, Tayo, talk to me about NeoSigno Sense. Right when they pitched, I saw you come out. You were like, "Wow." So
Yeah.
what was going through your head when you heard that pitch, my man?
So it's very personal for me because I run a diversity, equity, and inclusion firm, and I think a lot of times one of the things that's missed out upon when we're thinking about belonging and accessibility is just that the intersectionality of that, and you tackle that by saying deaf, blind, and a lot of times people just try to check the box or any of these things. And I love the attention to detail. I love the fact that you all are committed to testing and retesting. I'll be very curious to see and learn more about when you can test with deaf, blind folks, but the focus and everything I saw is in the right direction, and it's a real problem. I mean, you all put the numbers out there. These are things that many of us have the privilege of not even paying attention to, and so please continue to stay focused on that. It helps people to be seen, heard, and understood for who they really are, and I'm really excited to see the future of this.
Y'all, Tayo is telling you, just keep doing what you're doing, keep going, keep building. You're tackling such an important need. And with our innovation track, we have a winner over here. I'm getting it from the booth, and we got it. My man Tayo, he's talking to me. NeoSigno Sense, Raaghav, Soham, Columbus Academy. Gents, huge congratulations for winning the innovation track. How you feeling?
Yeah, thank you so much. This is really amazing, and I'm really happy to be part of this.
Yeah, thank you so much for the opportunity, and I think that this will really help move towards the mission of helping people who are both deaf and blind. So yeah.
Team NeoSigno, they're wasting no time. They're using this cash. They're getting in the game, building their venture, and absolutely going to change the world. Guys, huge congratulations once again.